Okay.
Cool. All right. Hello, everyone. Today we'll be presenting our year design project, Truman Social Media Simulation. We're Group 8, and we'll introduce ourselves. Okay, so my name is Tevin. I'm the project manager of this group, and I work primarily on the back end.
My name is Ellie, and I focused on the front end.
I'm Dory, and I've also focused on the front end.
I'm Sophie. I worked on the back end.
I'm Rizwan, and I also worked on the back end.
Okay, so just to explain the background of this project, according to research done by Dr. Wisniewski, there have been no formal studies done on applying and evaluating real-time interventions where teens were coached about identifying and responding to potentially unsafe online interactions. So our group has been tasked by the STAR Lab to implement features to a social media simulation platform known as Truman. The purpose of this project is to allow researchers to be able to utilize Truman to evaluate the effectiveness of online safety nudges with teens. And these nudges are a promising way to help teens to help teens be safer online, as teens often lack guidance for resolving risky situations on social media. And the researchers will act as fellow teens in the platform and will inject low-level risks to evaluate the effectiveness of these nudges.
So what is Truman? Truman is a social network simulation application that was developed by the Cornell Social Media Lab, led by Dr. Dominique DiFranzo. It's also an open source project that allows the researchers to simulate social media experiences and where they can have a platform to simulate these experiences and conduct their experiments. So within the feed of this application, all of the interactions, content, users, and notifications are all curated and created by the researcher. Within the study, like each participant is going to believe that this feed is real and unique to them. However, Truman did not have a chat feature, and this was a necessity for this project because teens often face the most risk within the direct messaging platform.
Okay, so as for our objectives, the two main objectives include developing and integrating a chat feature. As Ellie just mentioned, many predatory risks arise in one-on-one chat environments. And for the purpose of this research, it was really important to have a chat feature. And another main goal was to implement real-time intervention known as nudges that would be triggered when risky content is presented to the user.
Now we move on to the development session. So this is an overview of our development cycle. Essentially, everything starts from the prototypes STAR Lab research team provides to us. And this prototype will include information such as what kind of interface would the chat window look like, as well as the designs of different types of nudges. And then the next step for us is to implement the feature. And in the meantime, our team, as well as the research team, will also do weekly testing. And whenever there's a bug reported, we would go ahead and solve those issues.
So these are all the libraries, frameworks, and other technologies we use to develop our project. We use Socket.io, which is a Node.js library, to develop the chat feature. We use Node.js on the back end, and we develop locally. We use Pug to render the HTML on the front end. We used a free version of MongoDB Atlas to store data on the database. And we're also using AWS S3 to host images on the cloud.
So just to explain Socket.io in a bit more detail, this is an event-driven JavaScript library that's used for web applications. It enables bi-directional, low latency, and real-time communication between clients and servers. And this library essentially formed the backbone of our project. We wrote various Socket events when building our chat UI to handle the exchange of text, images, video, message reactions, and nudges between users.
So for the database for Truman, it's stored using a NoSQL database with MongoDB, and we have a total of 6 different collections that make up the database. These collections include actors or bots, conversations, notifications, scripts, sessions, and users. So our team was able to add the conversation collection, which utilizes the user collection. And we use it to store the conversation history between different users within the app.
Here are some code snippet of our conversation collections. As Ellie mentioned earlier, it is used to store the conversation history of the users. And on the left side here, we have our conversation schema, where we have some fields storing the general information of a conversation, like username, user ID of the two users, as well as whether or not one user is being blocked by the other user. And then it comes to the content array, where we store the actual content of the conversation. And on the right side here, we have the message schema. That's the schema we designed for each of the message. And you can see we have some fields storing where the message is coming from and where it goes to, as well as the message object itself, which stores the actual content. This can be text strings, as well as other reference to medias like GIFs, video, as well as pictures. And then at last, there's the nudge object. Since a message might trigger a nudge, that's why we want to have this field to record the information about a specific nudge, like risky scenarios, as well as nudge type. And if a message is just a normal message, it doesn't trigger any nudge, then that field will be null by default.
Our sponsors want us to host a project on AWS. This semester we did develop locally because after discussing with them, we thought it would be better to develop locally to save up on hosting costs. But during the production phase, we will be hosting it on AWS. Now, AWS has EC2, which can help us manage scalability. For example, Truman uses Node.js and of course MongoDB as the database, and EC2 will allow us to create Linux instances of both Node.js and MongoDB once it's deployed to AWS. And this can help us manage scalability based on how many of our participants we have for the research.
So now we can move on to Truman's features, beginning with the user flow. This diagram represents a series of options as a user explores Truman. So we begin with user login or user sign up. So a user can either log into a previously made account or they can create an account. And then once they do that, it brings them to the home or feed, or the home where the feed is shown. And from there, the user has the option to add a new post, manage their account preferences, like their email, name, location, bio, or password, or they can interact with posts like comment and like, they can view their notifications, or they can open up the newly added chat interface and either go into the Discover tab or the Recent tab to pick a partner to chat with.
So just to give a summary of our chat features, the first feature is active users. So all users that are connected to the chat UI can be seen with their profile pictures. And also there's bi-directional messaging. So you're able to send text, you're able to send media, such as images, GIFs, and videos. A limit of 10 megabytes was set to avoid users sending excessively large files. And if a user tries to send a file over 10 megabytes, they'll receive a pop-up indicating that the media is too large. We also added message reactions. So almost like Instagram messaging, where users will be able to react to a text bubble, either from a chat partner or their own message bubble with like different emojis. There's also chat notifications. So if a user sends a message to another user and that other user does not have their chat open, notifications will be displayed with the number of unread messages there are. We added a Discover tab, and what the Discover tab represents is that all users that you don't have a prior conversation with will be displayed in the Discover tab. And then in the Recent tab, it shows all the users that you have a current conversation with. And you can also view the chat history of all those partners you have a chat history with.
So now to summarize the nudges that we've created. So these nudges are triggered in response to the different low-level online risks. So we've implemented 3 different nudge types that have been designed based off previous research done at the STIR lab. So these nudge types are general warning, which is going to be a pop-up in the screen that provides like a general warning message about the content that was sent that can then be dismissed. A sensitivity filter is basically, it's going to display over the message that's sent, and it's going to give the user 3 different actions they can take. So they can view an informational page, they can either delete the message, or they can show the content of the message. And then lastly, the guided actions nudge is going to pop up right above the text input, and it's going to give the user like 3 different options of like guided responses that they can send to respond to the information, or they can also have the option to block and report that user.
So now we can move into the context of the study. So some high-level questions that could be best used to explain the goals of the study would be, first, how well does the curated environment convince the participant that it's based in reality? So how well can we create the simulation so that the participant thinks that it's a genuine conversation with a researcher or with another user versus a researcher? How do online threat responses differ between teams that are at a high risk versus teams that are at a low risk? And which type of nudges are most effective at helping teams mitigate predatory risks with by themselves with a little bit of guidance?
So here are a list of scenarios designed for the studies. There are in total of 4. And the first scenario, we have a general warning nudge that will be triggered when a researcher asks for information about a participant's school. And in the second scenario, a sensitivity filter nudge will be triggered once the researcher sends a phishing link. And for the third one, this is another general warning nudge, but this time this will be triggered by an image with explicit content. And then lastly, we have the guided action, which will be triggered when the researcher tries to acquire a participant's address. And we will dive into more detail later in our demonstration.
Okay, so moving on now to team reflection. Some challenges we face, a major challenge we faced at the beginning of this project was deciding if we should integrate an open source chat interface or we should create our own. So after talking among ourselves, even to Dr. Lineker and our sponsors, we decided that it was best to create our own chat interface, as we would be able to tailor it exactly how we wanted it from a functional and a visual perspective. Another challenge for us was just integrating features generally in an open source project. It presented a steep learning curve for us because many of the technologies we as a team were unfamiliar with, such as using Pug, Socket.io, and even AWS S3. And lastly, another challenge, which is team organization and work distribution. We initially had a slow start at the beginning of the spring semester, but we were able to finally work together cohesively and speed up the development process. Now, to talk about successes, a major success was just excellent support from the STIR Lab and Dr. DiFranzo when it came on to resolving issues in regards to Truman or just general help. We were also able to have peer programming sessions with each other internally through Discord to resolve issues and work on features. And we're able to fully integrate a chat feature from scratch into Truman, and also within that chat interface, implement all the required nudges and corresponding risk scenarios as required by the STIR Lab. So those are major successes for us in this project.
So as for the future plans for this project, we'd like to implement a mobile version, so it would be compatible for that. The lab would also like to refine these nudge designs based on different team feedback that they would get through more research. We also want to create a researcher administration tool, which would provide one researcher the ability to manage multiple different actor accounts. And then it would also give them the ability to be able to show or hide the nudges. We also would like to make this chat interface customizable and open source so other researchers can use it. And then finally, we'd like to move towards a more machine learning based approach to trigger the nudges. So now we're going to move on to the demonstration. Can everyone see the demo?
Yeah.
Okay, so over here, I'm going to show first just some general features on Truman. So once you open Truman, you come to the feed page, and here the feed's going to be filled with different user posts. Right now, the theme is food, so that's kind of why they're all like this. But within a post, you have 3 different actions, so you can comment. You can also like a post, and you can flag it. Then from here, you can also upload your own. And then you have to add a caption. There's also this notifications page in the nav bar, and here it will show all of the different interactions that other users have with your own posts. And then there's the My Account and My Profile page. So here you can update more of your information and make it more personalized. And then in My Profile, you can see all of your posts as well as what other users on the site would see. So now we're going to move into the chat portion of this demonstration, which is the feature that we primarily focused on this semester. So the first thing we wanted to showcase was the notifications. So right here, this researcher has a new notification from this conversation. And then once you click it, it will go away. And then before we get into the sending messages, I just wanted to show the Discover tab. So this tab right here will show all active users on the site who are available for messaging. So right now we just have a test user there, but from this, you would be able to view their profile and also send them a direct message.
Okay, and from here, we just kind of show some features of the chat. So as you can see, you can send text-based messages, and a blue bubble represents a message that you sent. A gray bubble represents receive a message. We're also able to send images, and it also gives you like a display before you send it in case you want to switch the image. All the messages are also timestamped. We also added compatibility for GIFs as well, if you wanted. And again, everything is shown, all timestamped. And lastly, you're also able to send videos in this chat interface as well. And yep, it all works good. And if you look at the other screen, everything will be there as well. So that's just showing like the core functionality. Oh yeah, also reactions. So you're able to left click a text bubble and react to a message. And you can also react to your own message. And as you can see, it works in real time as well.
Okay, so now moving on to the different scenarios that we discussed earlier. So the first scenario, and then for demonstration purposes, we're going to show all the scenarios within this one conversation, but during the research, it would be done with different participants. So the first scenario we're going to go over is when the researcher tries to get school information from the participant, and the nudge that's going to be triggered is the general warning.
So here, the researcher would start a conversation by asking if this teenager goes to a fake school, and
1 second. Yeah, I was pasting from. Let me try again.
There's a slight delay. 1 moment.
And since this is gonna be a school that doesn't usually exist, we would assume that the teenager would respond with yes or no. And that's when the researcher would proceed the conversation by asking which school do you go to? And then as we can see, that's when the general warning is being triggered. And you would notice that in this case, the message being sent by the other user would blocked or filtered. This will be just a pop-up with some warnings that the teenager can dismiss. And in this scenario specifically, they are warning the teenager to not give out personal information to strangers.
So now moving on to the next scenario, it's going to be when the researcher sends a phishing link, and the nudge that's going to be triggered is the sensitivity filter.
So yeah, in this scenario, again, the researcher will engage the participant with some friendly text, and what they'll try to do is they'll try to send a phishing link, but disguise it as a meme. And once this phishing link is sent, and we'll see what happens. So once the phishing link is sent, the participant will receive a pop-up giving them the option to click here to learn more. And once they click here to learn more, you're taken to a risk information page. And this page will let the user know what information breach it is, and let them know that that link could possibly be an information breach link. It also explains to the participant the different examples of information breaches. And lastly, it tells user how to identify an information breach link and what they can do if they feel like they've received an information breach link. And then also, the user can choose to delete the message if they don't want to see it. And as we can see, the text bubble just says deleted message instead of the actual link. And if they choose to show the message, then they'll receive the actual link that was sent.
So the next scenario we're going to go into is when the researcher tries to send an explicit content image, and then the general warning nudge will be triggered again.
Again, in the scenario, the researcher starts a conversation with the participants, and as usual, it's pretty suspicious. When the researcher sends an image, it'll make the general warning nudge pop up. So just upload the image, and as you can see, it is explicit content. So once the image is uploaded and sent to the participant, this general warning nudge pops up, and it's similar to the first one that you saw, but this one is different because it's specifically for the explicit content image. So you can just click on dismiss on it as usual, and as you can see, the image is still blurred out because we don't want to actually exposing of the participants to sensitive content with the research.
So finally, moving on to the last scenario, which is when the researcher tries to get the address of the participant, and the nudge that's triggered is going to be the guided actions nudge.
So this is the last of the nudges that we've implemented. This is triggered by more of an information breach. So in this example, the researcher will ask the participant's location, and then they'll ask again in a more specific manner. So the participant says Orlando. And then once the researcher asks for a more specific location, the nudge, the guided actions nudge comes up, and then there's a few options as to what the user can do. They can either pick from one of the three pre-made texts and will automatically send, or the user can send their own message. They can simply exit out the card and just ignore it, or they can block and report the user to terminate all interactions between the two. Okay, so we'd like to take this time to thank our committee members for joining us today, and our sponsors for supporting us throughout this entire process. We wanted to say thank you to Zainab, along with Luke and Thomason, for creating very detailed prototypes for us and making themselves available for all of our questions and concerns at almost all times of the day. And thank you to, and the StirLab team was a pleasure to work with, and we greatly appreciate the amount of support that you've all given us in the past 2 semesters. And also we want to give thanks to Dr. Dominic DeFranco for explaining the architecture and inner workings of Truman for us every single time we had structural questions. And finally, we want to give thanks to Dr. Wisniewski for all of your support and for helping integrate good development practices and for keeping us on track.
All right, so thank you guys, and if you have any questions, feel free to ask.
I don't have any direct questions other than just that I'm insanely impressed with just everything you've done. I've only seen like snippets of a little bit of what you've done. Like I knew the general concept of what you were doing and some of the scenarios and how you're looking at using Truman and stuff like that, and helped out with some minor technical things here and there. But getting to see like everything you did, all the different scenarios, the building up of the different interventions, some of the technologies and techniques and front-end techniques you had to employ to make those work is not non-trivial. Those are super hard. Those are things I've had some of my grad students have to work on, or I had to build myself in other experiments. You know, you just like dimming a photo or putting overlays on photos or creating some of those pop-ups or creating things and having those respond when certain conditions happen. Those are not easy, as I'm sure you all know. And I'm just crazy impressed. I mean, the fact that you're able to join into a project that already existed that I did very little to allow, and very little inside of there for others to come in and play around with. It's just usually my messy, BS code and stuff like that. I was never expecting other people to play with it. To be able to kind of jump into that, build this amazing new feature, and then not only have that feature, but have all these great interventions and situations and scenarios can build into that. I'm beyond impressed. So thank you so much. I'm really excited about trying some of these features and techniques in my own research going forward. I know that some of my grad students might be interested in playing with this and just mixing this into the larger Truman repository of features and stuff like that is just absolutely incredible. So just thank you so much. This is amazing.
Yeah, and Dominic, I'd love to have a touch base meeting with you and Zainab after the end of the semester so we can talk about her study design and moving forward too.
Absolutely. I would love that. I would absolutely love that.
We've just been heads down all semester, so.
I bet.
Congrats on writing your own chat. Your own chat code, very good.
Thank you. And well, I mean, thank you guys for coming here, for viewing our presentation. We really appreciate it. And I'll just thank you to the team as well.
And they will email you the editable PDF that you can fill out and send back to me. That would be great.
Yes.
So the team will email that? We thought Dr. Wisniewski was emailing that.
I
No?
think the team emails it to us because I fill it out too.
Okay,
Yeah.
okay.
As long as you get it. And
Did you have any questions, Jackie?
I just had a quick one. So I understand that you really had to kind of self-teach with regard to some of the software that you utilized. Just a couple quick questions. Do you feel that there's any particular software or language that you felt if it had been included in your curriculum would have helped you? For example, I've seen a couple teams have said in the past, if there was a mobile app course here at UCF, that might be helpful if you look at your future plans. So like I said, just curious if there's anything you would have liked to have seen maybe in your coursework that would have made this a little bit easier for you.
Yeah, I think for us, one of the things that tripped us up like the most in the beginning was Pug. Like we had a lot of meetings about it because honestly, like conceptually understanding it was really hard because we thought it was like front end code, but it actually was in the back end. But I think that's like a really specific thing. But I think more generally, just more coursework experience with kind of like jQuery and just like JavaScript and updating the DOM. Like personally, in any of the courses I've taken, like I never had much experience with that. So I think learning that through coursework would have been also really helpful.
Yeah, for sure. And then just curious, you mentioned that team organization and work distribution was a challenge. Can you explain that a little bit? Because that seems like it'd be super easy. What talents do you have? Okay, you do this, you do this, you do this. How come you guys struggled there?
Yeah, we struggle because some tasks were just harder than others. And what would happen is that some tasks would get done and some tasks wouldn't get done. And then that would cause like a delay in the workflow. And
Okay.
it would be the case where sometimes another person working on a specific task would have to help on the like another task as well that wasn't initially assigned to them. So that's why it was a bit of a challenge initially, but we figured out a rhythm and we were able to get it done.
Yeah, your presentation definitely demonstrated that you shared the wealth with regard to the workload, and that's a good thing. You never like to see teams that are heavy to one or two members. So, congrats on sharing the wealth, so to speak. And then I was curious, the future plans are that you delineated are impressive. Now, is that a new to-do list in the STIR lab, or is this something that you'll complete before you submit your final?
No, I believe that this is like kind of what the STIR lab would want to
Okay.
do. Yeah, like in future senior design projects, because they're all pretty big tasks.
They are, yeah. No, I think it's great. Which is wonderful. It just kind of builds from year to year.
Yeah,
But
definitely.
again, yeah, just very impressed with what you've done. It's true. Every little item that you take for granted was hours and hours, if not days or weeks of work. So great job, and congratulations on graduating.
Thank
Thank
you.
you.
Congratulations.
Thank you.
Thank you.
Congrats.
So Zainab, since you were the one closely mentoring this team, did you have any questions for them?
Yeah, I was, I guess, wondering, I mean, since we've mostly talked about the technical side of things, did you guys have, personal thoughts on how you think nudges should be implemented for teens, or, how you in your teenage would react to them or respond to them, given what you've implemented? What are your thoughts on it?
I definitely think the interactive ones were like the most cool to me. Just because I don't know, I feel like given options, like that's the most effective because then it's forcing them to think. Whereas like the general ones, like I think they're effective, but I don't know, like if I was a teenager, if I would have read the whole thing. So I think the interactive ones are definitely cool.
Nice. This might align with some of what Thomason's working on. He's getting feedback from teens. And then were there any like I know we talked about like teamwork division, but any other lessons learned that you guys would like to share?
I mean a big lesson I learned, before coming to Syrian design, I thought like a bunch of meetings were overrated, but I realized like actually meeting with your group is really important because there were times where everyone just kind of had their own thing going and we kind of lagged on internal meetings, but if we had been consistent across the board, maybe we would have avoided that initial slow start in the beginning of the semester. So yeah, just communication and meetings are definitely really important for a successful project.
So you did two types of code for this project. One is building on an existing open source code base, and the other one is building something from scratch. Which one did you find harder?
Definitely building on
Yeah.
top of it, just because
Integration.
like yeah, when you build from scratch, at least you will understand like every single
Yes.
part of it because you wrote it. But
You
just
wrote it,
like
yeah.
like getting used to the code base, figuring out what all the files are and like where everything is. I think that was definitely why it was slower in the beginning, because just figuring out how to do stuff and like where to put it was a lot harder than like once we got the flow of like where everything goes, it was kind of just grinding it out from there.
But do you
yeah,
think
again.
you could have built Truman from the ground up in the same amount of time of learning the integration?
No, I definitely think that integrating would take less time than doing the whole thing. But yeah, we really appreciate all the help. I think that really helped us like get a lot of productivity being able to meet with.
Yeah, and Dominic, thank you so much for supporting them on your code.
Absolutely. I've always found it to be the case as well. You're not alone in feeling that way. It's one of the reasons why I wrote Truman from scratch, because I was frustrated with other tools and things. But you will learn as you get into other environments and things like that, you almost never get the opportunity to just build something yourself. You're almost always building on what others have, and that is significantly harder but it's also necessary for a lot of the systems things we have. So I'm glad you got some experience in doing that, because so much of our classes that we teach and do stuff like that don't show those skills. You know, what I mean, that are going to end up being so vital later on.
Definitely.
All right, well,
Well, with that, it looks like it's a wrap. Thank you, committee, for doing this, and thank you, students, for enhancing Dr. Wisniewski's research.
thank you, thank you.
Yep. Great.
Thank you.
All right.
Thank
Thanks,
you.
everybody.
Bye, everyone. Bye.
Yeah.
Bye.
Bye. Take care.
Who's in charge of sending it?
I can send it.
And make sure that you put my email so they know where to send.
I'll hang up now. Good job, everybody.
Thank you.
Yeah,
I'm just like sitting there, like staring.